Alright, so here's our final video for chapter 11 project, and it's the section 4 that we want to work on. Section 4 is creating an argument based on what we've learned about the Cullen-Dillon twins. At this point, you should have at least one hypothesis that you feel like has evidence supporting it. That's a hypothesis that you've looked at. So at this point, you've taken whatever version you have, A, B, or C, and you've looked at the FTO gene, the RNA polymerase gene, and the ribosome gene, and you've converted each twin's DNA into RNA and mRNA codons, and any RNA codons that are different between the twins, you've translated into amino acids, only those that show differences, and those differences are mutations, right? So any codon between the twins that looks mutated or different, that's the ones you translate into amino acids. At that point, it should have provided evidence to show which genes might actually explain how they're different. And if you get the same amino acids for the two twins, of course, that was a gene that you no longer can hypothesize to explain their difference. So it must be whichever gene you found or genes you found that have different amino acid sequences, again, depending on what version you have, A, B, or C. Once you have selected and you feel sure about a hypothesis you want to proceed with, that it seems the most likely or the most supportable with your evidence so far, that's where section 4 comes into play, and that's where you create your report to report on your findings that supported your hypothesis. I'm going to show you Inquiry Project Argument Google 2 as my example, but just know that there is a version, Google 3, as I mentioned in the prior video, that gives a little more support and makes it a little easier to know which resources and outside ideas you can pull from to help answer in your report. But let's go through Google 2 version, this one right here, and I'm going to show you kind of how I would proceed with the first question, or trying to complete the first question, and then use that same example to complete the rest of the argument. So clicking on it would reveal this document right here. I'm going to quickly go into presentation mode and just show you the overall look of the argument slides, or the report slides. This first slide just tells you what this is about. This was the original worksheet you were working on, where you have your hypotheses, and where you also reflected on your hypotheses and modified them, or got rid of them, or held them if you needed to, right? This worksheet. That was section 3. Now section 4 is the argument, right? The report. Each slide represents one of these parts. Slide 1A is 1A. The second argument slide is slide 1B, and it talks about how the mutated protein caused the differences in phenotype of the twins. The third slide in this worksheet, or the third page, is about this 1C, describe the effect the mutation has on cellular processes of organism. And the fourth page or slide for the report is 1D, and it's based on you using DNA evidence from part 3, the work you did in part 3 of the worksheet, as evidence in your argument. Again, that original worksheet you had in your doctor file had 4 sections, and the section you're working on right now is the final section, section 4, where you argue or report on your findings. We're going to look at the first slide and try to meet these needs. So for each slide, we want a supportive image. That's what we're going to do first. We're going to find an image that supports the ideas that we want to argue on slide 1A, and that is description of how genetically identical twins could have any nucleotides different from one another. So I'm going to go to Google and I'm going to pick an image that I feel like has to do with genetically identical twins, and if I can find a picture that shows differences between them, even better. So I'm going to exit the presentation mode. I'm going to go to Google Images right here. And I'm going to write identical twins, identical twins with mutations. Let's see what happens. So I Google that, and let's see what images I get. So it does show some twins, examples of twins that look different, and clearly there's some surprising results. But what I'm not getting is an image that shows the cellular process or the genetic process, right? I'm getting pictures of different twins, neither of which is Cullen-Dillon. I haven't yet found any picture that has any kind of genetic or cellular basis for identical twins. So what I want to do is change my results a little. Well, maybe this is an option, right? So it's always about combing through and picking the right image. All right, this could be a good. Let's see if it'll let us view the image on the original page. All right, didn't want to grant us access on this. So this Googled image potentially would be perfect because it looks like it shows two twins that experienced mutations, even though they came from the same zygote or same original fertilized egg, right? It looks that way, and it looks like it's focusing on a particular area of cells of their body, but it's blurry and it's small, right? So let's visit the page and see what we get. So the page here has a very technical, this is a professional doctoral report, and it says distinct point mutations in monozygotic twins, and it says with Down syndrome. So this could be an interesting article, but we don't need the article, we just wanted the image that they were using. But the image, let's see if it's available. So as we can see, the image isn't there. So we would have to buy or purchase this to see it, so we can't use it, but this would be perfect. But it does give me an idea. If we Google point mutations, identical twins, let's see if we can improve our results. So point mutations, identical twins. And let's look at images. Let's see if we get it. So this is a potential picture that could work. It shows the difference between the two twins, and we could adjust this. We could make our own image if needed. We probably don't want to take the time to do that. It takes work, right? So, but it doesn't show any mutation, but it does show how the monozygotic twin separates to make colon-Dellin. So we could potentially use this. Let's just see if there's another good picture, though. There's this image again, but I'm not sure if it will come up more clearly. Nope, it won't. So even though that's perfect image, we just don't have access to it. So I'm going to adjust our search one more time. I think it's probably easiest for us if we just, when you're answering that slide, to Google monozygotic twins and choosing a photo below. I'm going to show you the power of PowerPoint. So what we're going to do is we're going to right click and copy this image. We're going to use this image and we're going to take it to, whoops, we're going to take it to the project right here. So slide 2, it says place model or graphic here. And this is the slide we were talking about trying to complete. This is slide for 1A, which was this one, right? 1A, the very first one. So the very first part of the argument is trying to talk about how twins form or how they could have become different, right? So I'm going to remove the text and place the image right here. And you can see I can fully adjust it. Google Docs makes it easy to copy and paste. Remember, you right click and you get the copy paste function, okay? What I'm going to do though is I'm going to add a shape, and I want to do a box. And the question is why, right? So what I want to do is I'm going to put this into a box, this section right here. Now it's filled in, so what I need to do is adjust it. So I'm going to make it transparent, and I want to make the color, let's do orange, because that kind of stands out. And I want to make the bar wide, so you can see how I do that, so just match it. And so I'm going to talk about this section right here, and you can see I'm making my own picture here, and but I'm only going to talk about monozygotic, because that's the way Dylan and Cole are. All right, it says, website 15 could help give some information to help with my first argument. But if you look here, slide 1A, 1B, 1D, and 1C, they all have sentence frames or help writing your report. So some of you could write your own report and don't need these blanks, and if you want to, go ahead. But for the rest of you, you can click on these links and you can just use the words that I've set up for you to write your report for each slide. So I just want you to see that. For each slide, there's sentence frames and advice or links to help you find a little information to help fill in the blank. But if you fill in the information in the blanks, you're creating a report for each slide. This is the third slide for the third argument. Has the same, has some links, filling in the blank, and placing a picture here. So they're all the same format, and the final argument or report page or slide has its sentence frames and placing an image. Let's go back to this one though. It says division of the embryo must have occurred, and then it says go to website 15 for help. Let's just see where this takes us. Let's see what happens. So this linked us to the resource guide, and you can see we have links to help us with all different kinds of ideas. If we need help remembering the purpose of genes, proteins, and DNA, we can click on one of these links. If we need help with transcription or translation, you choose those links. If you need help understanding the function of RNA polymerase or ribosomes, click on those links. So when would you use this? If you felt like the RNA polymerase gene was the mutation that might be the cause of the difference in twins, if that's the only gene you had that had real differences or mutations, then you're probably using RNA polymerase as your hypothesis. But if you couldn't really remember completely what RNA polymerase did, you could easily click on this link and go to an activity to remind you of just what RNA polymerase does and how, and then you can creatively try to come up with some explanation of why that particular protein from that particular gene could have caused differences. And the same goes for ribosomes, right? So if your ribosome gene is to blame, it says if you need help understanding the cause of mutation or the results of a mutation, here are many links that you can click on or search words you can Google to help you remember a little bit more about mutations or how they impact things, which will be one of the slides you have to argue about. If you need help with an argument based on brothers having different eating behavior, so let's say the only hypothesis you had was you think the brothers eat differently. Well, you could click on this link and it might provide evidence to say that it's their lifestyle that's causing them to be different, not mutations, right? However, keep in mind that if you did find a mutation difference between a particular gene, it's going to be hard to ignore that. So make sure you choose the best hypothesis to support. But this would be a fun challenge for anyone. It says if you need help explaining the process of producing identical twins. These are the links for us. 15 and 16 we want to use because we're trying to answer. Well, there we go. Because slide 1A is trying to answer how identical twins form. So we're most interested in these links about explaining identical twins. So let's click on this and see what we get. All right, so when we clicked on this link, it took us to a file I saved for us and, that you have access to. But notice it's the Word document version, and when you click on a Word document version, it doesn't appear to allow us access. Watch this, say a site can't be reached. So when you want to use the resource guide, and if you click on any link during the argument point and you click on it and it takes you to the Word version, currently the links don't work with Word. Our security systems with the district just don't allow it. So what you need to do is go back to the original report page, and I have the Google Doc version of the same thing, and those links work. And let me demonstrate. So here, let's see here. Here is the same document in Google form that you could click on from your Google class, and we have, and I even added more slides about trying to explain identical twins. But if you click on this active link is here, and it does in fact work. And then we would watch this video from this website in order to get a better idea of how it might have formed. If we're still feeling like we don't know. So if we're still not sure of when we think the mutation happened between colon different to allow them to be different, watch this video to try to get a better sense of when you think that happened. So I'm not going to play it, but it's only 33 seconds long. So you'd watch the video. All right, so after watching the video, you want to decide where in this picture do you think the mutation happened to make colon Dylan different? Which one of these points here, or sections of division. The initial fertilization,